Okay, in this question, we want to look at this enzyme immune assay test. What that means is basically they're screening blood specimens to see if they have certain antibodies, and the antibodies would indicate the presence of HIV. It's a pretty accurate test, but as we'll find, it's not always correct. So we're going to look at these probabilities that we're given. Some of what we're given is in the table and some is in the statement afterwards. We're going to make a tree diagram to figure this out, okay? Because when it comes down to it, what we want to know is what's the probability that the person has the antibody given that the test is positive, okay? So I'm going to move this down a little bit and I will make a tree diagram. Okay, so we can see that. Okay. So the first branch of our tree diagram, whoops, got to switch to the pen. First branch of our tree diagram is going to be antibodies present and antibodies absent. So, antibodies are only present in 1% of the population. So this is 0.01. They're absent in 99% of the population, so this is going to be 0.99. Okay? We get that from this sentence up here. 1% carries antibodies, 99% doesn't. You either do or you don't. Okay? The next line of the tree diagram that we're going to look at is whether the test is positive or the test is negative. And this is the information that we're going to get off this table. So if the antibodies are present, we're at this line on the table. It's a positive test, 0.9985, and a negative test is 0.0015. If we go to the row of antibodies absent, the positive test is 0.0060, and the negative, that's a 0, doesn't really look like it, and the negative test is 0.9940. And then remember what we do with tree diagrams is we just multiply straight across. So we multiply 0.01 times 0.9985, and we get 0.009985. We multiply 0.01 times 0.0015, and we get 0.000015. We multiply 0.99 times 0.0060, and we get 0.00594. And we multiply 0.99 times 0.9940, and we get 0.98406. Now, since we're asked for a conditional probability and we are asked given that the test is positive, we're only going to look at where the test is positive. We're going to limit things down to there. So the denominator, let me grab a different color just to try to keep things a little bit straight here, okay? So the denominator is going to be the sum of these two numbers that I've boxed. And the reason for that is because we can only look at the outcomes that gave us a positive test, because it's given that the test is positive. That's our narrowing criteria. So we get 0.015925 when we add those together. Now, given that the test was positive, which we've just done, what's the probability that the person has the antibody? Well, we can only, for the numerator, look at the ones where the person actually has the antibody present. That's an 8, and that's a 5. I don't know why my pen's going crazy. And when we do that division, we get for a final answer 0.623. 7.